Alright, so these are instructions on how to use Desmos for graphing calculator stuff. This program is actually a lot more user-friendly than graphing calculators. I would love to use this for everybody, frankly, but the reason I train people on the TI-84 and other similar calculators is because that's what is allowed on the ACT and other state tests. So it's more, I guess, useful for your future to learn about the TI-84, but in these crazy times, Desmos is going to work just fine. So learning to use Desmos will be, in fact, a lot easier. And this is just an online program. I'm using it as an app right now, but you can find this online. There are links on my Canvas to Desmos. The other great thing is that you can log in, like you can see in my upper right-hand corner. You can log in with your Google account, your school Google account, and you can save things that you've graphed before, so if that's helpful for you. Some of you have used Desmos already for performance tasks. But anyway, I love Desmos. It's super easy to use. So I'm just going to go really quickly over all of the things that are in your notebook for the instructions for how to use a graphing calculator. In Desmos, what I'm going to do is I'm just going to graph x squared. So what you do is you type in, actually I'll start with y equals, y equals x squared minus 6x plus 8. So you do need a y equals in Desmos, or else it's not going to know what you're doing. So I just typed in the quadratic that's in your book on page 51 that we sort of used as a warm-up in class. So I have now this graph, and you can move it around, you can zoom in. Desmos is super easy. Calculators, you cannot do this. So like if you have, for example, a quadratic where you can't see the quadratic in the calculator, you have to do some sort of guesswork. But on Desmos, you just zoom out till you find it. So it's great. The first instructions is just setting your window. So that's not, that's just you zoom in and out until you can like sort of see all the important parts of the quadratic. The next thing it gives you instructions for is finding zeros. So that means x-intercepts. Finding the x-intercepts on Desmos is super easy because you can just see them right here, right? And even if there weren't numbers there, you could click this and get a point. So I get the zeros 2, 0, and 4, 0 that give me those two zeros. Easy peasy. So our zeros are 2 and 4. The next thing it tells us is to find the vertex. The vertex on Desmos is also super easy because it highlights it as an important point. So you can just click on that point and it'll give you 3, -1. That's our vertex. Then finding y-intercepts. Excuse the sound of me turning pages. Finding the y-intercept is just as easy. You just click where the where it crosses the y-axis. I guess the hardest part is just knowing where to look for these things. Just remember what it means to have a y-intercept, right? It crosses the y-axis at a certain point. The last thing is finding intercepts. So some questions will say, for example, like if Johnny is throwing a ball, at what times is it going to be 14 feet in the air or something like that? And maybe I'll change around my graph so that it fits more the scenario that I just said. Let's see. We'll make this +6. Okay. Okay, so say this is Johnny throwing a ball in the air. And the question says, when is it going to be 14 feet in the air? So what you do is you make another line over here. You just click down there or you hit enter and there's another line available for you. Then you do y equals and you just put where you want. So we're wondering about the height of 14. So I graphed a line, a horizontal line at 14. And that will show you where the 2 points where it crosses that are the 2 points where the ball sort of hits. Like if you imagine him throwing the ball and there's this imaginary line, there are 2 points where it hits that line on the way up and it hits it on the way down. So the question might specify which one it wants, but there are two answers. One is 1.268 and the other is 4.732. Those are the two times where the ball hits 14 feet in the air. So Desmos is super user-friendly, and feel free to use Desmos for the rest of this unit. We'll be learning a lot about how we apply quadratics in real life. And Desmos is incredibly helpful for all sorts of things. And that's that.